Alright, so here's my demonstration video of the recrystallization process. So of course I don't have the materials that I actually need to do it in real life, but I have some pretend ones here just to help with the visualization process. So I have here my pretend, which is not in here, my pretend organic impure substance. I have here my solvent. This is my pretend hot plate. Here's my beaker, my filtration funnel, and my fluted paper. So what I want to do is that once this reaches close to its boiling point, once the solvent reaches close to its boiling point, I take it up and I keep putting it into where the organic solid is, and I'm pretending that there's like a little magnetic stir in there, and I keep putting it in until I can't see that it's dissolving anymore, and then I even put in a little bit more as an insurance. So I put in until it's just above what I need to dissolve the substance when the solvent is hot. So I'll pretend that this is enough right here. So if I sense that there is oily impurities in here, or color impurities and whatnot, I would use charcoal. So I would take this off, and then I would wait for it to be a little bit below its boiling point, and then I would put in some of the charcoal, and I'd mix it up, and then I would put it back onto the hot plate and wait for it for a little bit until it reaches its boiling point again. So you only use charcoal if you know, or if you suspect that there's oil or colored impurities or colloidal impurities. That's the only time that we use charcoal. So I'll pretend that I have some charcoal in here, and this is my compound. I'm going to put it into the filter. And the reason why we use the fluted filter paper to filtrate this is because fluted filter paper has a bigger surface area than regular filter paper does. And it also helps that it doesn't touch the sides of the funnel. So once I see that this is pretty much done, I just do it like little bit by little bit so that it doesn't mess it up. And then I have a little bit in the bottom here. I wait until I have completely drained this. And then I have my filtrate in the bottom here. So this is gravity filtration, and we use it in order to separate the impure components that were bonded to the carbon with the charcoal, and it stays up in the filter. And so after we have this, we very, very slowly cool it until we start to see some of the crystallization happening in the bottom. And then we cool it very, very rapidly in the end until we have our crystals. And then I don't have it here with me, but I'll explain what we do with the suction filtration. So with the suction filtration, we take what's in here, the filtrate, and we have a Buchner funnel. We have a paper over top the Buchner funnel inside. We first take a little bit of the solvent, we make it damp so that it sticks to the bottom of the Buchner funnel. And then we pour the filtrate into the Buchner funnel, and then we turn on the thing, it sucks it, and it'll suck the things out of the Buchner funnel. It'll suck away the liquid, and it'll leave us with the pure crystals on the top where the Buchner funnel is. So then as soon as we have those, we let them dry for a couple of days, and then since we have that solid that solid compound, we can then use that for analyzing. So I should also touch and just make reference. So for impurities with higher solubility, those are usually the ones that we get when we're doing the cooling process, because then things that are more soluble, as it cools down, they'll start to crystallize, and then that's how we get those impurities that have higher solubility.